crystals used as clocks to time magma storage before a volcanic eruption occurs. This is by Science of Cycles, Mitch Batters. The molten rock feeding volcanoes is stored in the Earth's crust for as long as 1,000 years, a result which may help the volcanic hazard management better forecast the eruption of volcanoes that could take place. This is research from the University of Cambridge in England. They use volcanic minerals known as crystal clocks to calculate how long magma can be stored in the deepest part of volcanic systems. It's the first estimate of magma storage times near the boundary of Earth's crust and the mantle, called the MOHO. The results are reported in the journal Science. Dr. Ewan Much from Cambridge's Department of Earth Sciences and the paper's first author said, "This is like geological detective work. By studying what we see in the rocks to reconstruct what the eruption was like, we can also know what kind of conditions the magma is stored in, but it's difficult to understand what's happening in the deeper parts of volcanic systems." And he goes on to explain, determining how long magma can be stored in the Earth's crust can help improve models of the processes that trigger volcanic eruptions. Co-author John McLennan said, also from the Department of Earth Sciences, quote, "The speed of magma rise and storage is tightly linked to the transfer of heat and chemicals in the crust of volcanic regions, which is important for geothermal power and the release of volcanic gases to the atmosphere." End quote. The researchers studied the Boguram eruption of the Teistereykir volcano in northern Iceland, which occurred about 10,000 years ago and was fed directly from the Moho. This boundary area plays an important role in the processing of melts as they travel from their source region in the mantle towards the Earth's surface. To calculate how long the magma was stored at this boundary area, the researchers used a volcanic mineral known as spinel, like a tiny stopwatch or crystal clock. Using the crystal clock method, the researchers were able to model how the composition of the spinel crystals changed over time while the magma was being stored. Specifically, they looked at the rates of diffusion of aluminum and chromium within the crystals and how these elements were zoned. Quote, "Diffusion of elements works to get the crystal into chemical equilibrium with its surroundings." This is what McLellan said, explaining if we know how fast they diffuse, we can figure out how long the minerals were stored in the magma. End quote. So the researchers looked at how aluminum and chromium were zoned in the crystals and realized that the pattern was telling them something exciting. They knew about the magma storage time. The diffusion rates were estimated using the results of previous lab experiments. The researchers then used a new method combining infinite element modeling and Bayesian nesting sampling to estimate the storage timescales. Much said, "We now have really good estimates in terms of where the magma comes from in terms of depth. No one's ever gotten this kind of timescale information from the deeper crust." End quote. Calculating the magma storage time also helps the researchers determine how magma can be transferred to the surface. Instead of the classical model of a volcano with a large magma chamber beneath, the researchers say that instead it's more like a volcanic plumbing system extending through the crust with lots of small spouts where magma can be quickly transferred to the surface. The second paper by the same team, recently published by Nature Geoscience, found that there is a link between the rate of ascent of the magma and the release of carbon dioxide, which has implications for volcanic monitoring. We know this is one of the gases that is emitted by volcanic eruptions, tremendous amounts of carbon dioxide. It's something that also heats up the Earth. Without volcanic eruptions of carbon dioxide, we would have a frozen planet, from what the geologists explained to us. This is from what I remember from past readings. The researchers observed that enough carbon dioxide was transferred from the magma into gas over the days before eruption to indicate that CO2 monitoring could be a useful way of spotting the precursors to eruptions in Iceland. In other words, it's the CO2 eruptions that have to be monitored because they'll show the increased level before the eruption takes place. Based on the same set of crystals from Boguram, the researchers found that magma can rise from a chamber 20 kilometers deep to the surface in as little as only 4 days. The research was supported by the Natural Environment Research Council, NERC. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.